Here we have a function f of x is equal to the square root of x minus 2, and we're given a value of a equals 2. First, we're going to show that f is 1 to 1, and then we're going to find f inverse prime of a, and as you recall, f inverse prime of a is 1 over f prime of f inverse of a. In this case, a is 2. For part A, to show that f is 1 to 1. First, let's recall that f is 1 to 1 if whenever we have different inputs, we have different outputs. So what we're going to do is we're going to suppose we have outputs that match. Suppose f of x2 is equal to f of x1. Now f of x2 is going to be the square root of x2 minus 2. F of x1 is the square root of x1 minus 2. And let's just crank on this using algebra. We can square both sides. So x2 minus 2 would equal x1 minus 2. And if we add 2 to both sides, we are forced to conclude that x2 was equal to x1. So I only have the same outputs because I had the same inputs. Now that might not be terribly illustrative. So let's look at an example of a fail. If we let g of x equal x squared and try the same thing that we just did, say g of x2 is equal to g of x1, then that would mean that x2 squared is equal to x1 squared. But when I square root both sides here, I'm going to write down that x2 is equal to plus or minus x1. So I'm not forced to conclude that the outputs matched because the inputs matched. I could have a situation where the inputs don't match, but the outputs do. We don't have that situation here. This is sufficient to show that f is 1 to 1. And it actually would be appropriate for me to say then f is 1 to 1. We often like to write down what it is that we were trying to show. We being math people. Next part, find f inverse prime of a. And since f is 1 to 1, we know we can use this formula. Now, in order to use this formula, we need two things. We need the derivative f prime, and we need f inverse of a, in this case f inverse of 2. I've gathered together what we need. So let me rephrase. In either order, find f prime of x and find f inverse of 2. Let's go in the order I've written it. F prime of x is equal to 1 over 2 times the square root of x minus 2. Recalling that the square root of x minus 2 is equal to x minus 2 to the 1/2 power. Using the power rule, the exponent 1/2 comes out front, so we have that 1/2. And then we decrease the exponent by 1, and a negative 1 exponent means a square root in the denominator. Now, separate from that, we need f inverse of 2. Remember, that would be the x value that gives me a 2 as an output. So I set the square root of x minus 2 equal to 2. Squaring both sides gives me x minus 2 is equal to 4. And so adding 2 gives me x is equal to 6. That is f inverse of 2. So as far as pieces fleshing this out, we need the derivative, and then we need f inverse of 2, which we know to be 6. Working with the denominator of this formula, f prime of f inverse of 2 is going to be 1 over 2 times the square root of something minus 2. Now let's make sure we're okay here. This is kind of the color coding that we have in the formula. But then the argument is f inverse of 2. We've just said that that is 6. So f prime of f inverse of 2 is equal to 1 over 2 times the square root of 6 minus 2. That becomes 1/4. That 1/4 belongs in the denominator of the expression for the derivative. And so f inverse prime of 2 is 1 over the 1/4 that we just got, and so is equal to 4. Let's see visually what we've just done. Our function is f of x is equal to the square root of x plus 2. We know that to be the square root function that has been shifted to the right by 2 units. And associated with the output of 2 is an input of 6. So that's our f inverse of 2. And just for completeness, I've included a tangent line here. So this is the curve f. Now f inverse is going to be a reflection about the line y equals x. Well, the graph's a reflection anyway. And if the function f contains the point 6,2, then the inverse function contains the point 2,6. Right, so there's f inverse. And of course, f inverse has a tangent line there as well. What we found in our work was that f prime of x was equal to 1/4 at the point in question. So this slope of the tangent line here for f is 1/4. For the derivative of the inverse at that point, we got a value of 4. So the slope for the associated point on f inverse is 4. And we can see visually this has a shallow slope, 1/4 makes sense. And on f inverse this has a steep slope, and so 4 makes sense.